This video is going to take you through the review for the Chapter 6 test, which is going to cover 6.1 to 6.5. So we start with 6.1, which is law of sines. Quick review of the formula for law of sines. So the ratios are A over the sine of angle A equals B over the sine of angle B, and C over the sine of angle C. And we can group those in any two that you want to use. From the information you get given for law of sines, you'll have one complete ratio, and then you'll have a missing part of the second one. You'll cross multiply and divide to solve for what you're missing. There was an ambiguous case when we dealt with law of sines, and that was if you had two sides and the non-included angle. So if you were given, for example, if I had triangle A, B, C, and I was given angle B, like the one that's here, this is 30, side B, which is opposite that, 27, and side C, which is opposite C, which is 32. These two sides here, 27 and 32, obviously those are two sides, and then 30, angle 30 here is the non-included angle. So this is where you could end up with a second triangle. So we start by solving it the same way you solve everything else. You're going to set up, you have one complete ratio in B. So I'm going to say side B, which is 27, over the sine of B, which is 30, equals side C, which is 32, over the sine of angle C, which is what we don't know. So then 27 times the sine of C equals 32 times the sine of 30. And then I'm going to divide both sides by 27. And I'm going to let the calculator do the work there. So remember that you want to make sure that you're in degrees for all of these. And then I would just do 32 sine of 30 divided by 27. And I get 0.592 and so on. And I'm going to find the sine -1 of what I get for that. So without rounding it, I would just do sine -1 and pull back my answer. And I end up with 36.34 degrees. So we're going to call this, this is angle C. So we're going to call this angle C1. Put it over here on the left. So angle C1 is 36.34 degrees. So what we're going to do now is assume that there is an ambiguous case, or that there is a second triangle. And so I'm going to draw a little line and separate it out. And I'm going to say that the angle C there would be angle C2. And the way that we find angle C2 is by doing 180 minus what we got for C1. So I'm going to do 180 minus 36.34. And I get angle C2 is 143.66 degrees. So now if C2 that we just found and my B, which is true for both triangles, added up to be bigger than 180, then I would know there is no second triangle. But 143 plus 30 is 173. So there is an extra angle there, which means there are two triangles here. So I'm going to come back to the first triangle and I'm going to finish it off. So now I have angle B, I have angle C1, which means I'm left angle A1. All three of those angles still add up to 180. So I'm going to do 180 minus the 30, which is my original angle, and the one I found, which is 36.34. And I get 113. So that's the second angle that I'm looking for. So at angle C1, I have angle A1, 113.66. And then the last thing that I was looking for that first triangle would be side A. So I'm going to use the same ratio I used at the beginning for B, because I had one completed one, which is 27 over the sine of B, which is 30, would equal side A1, over sine of angle A1, which is 113.66. Cross multiply there. 27 times the sine of 113.66 divided by the sine of 30. And I get A1 is 49.46. And that's the last piece of information from my first triangle. So now I've got to finish out my second triangle. So there's still 3 angles in that second triangle. I still got given the same first one, which is 30 degrees. I found angle C2 is 143.66. So I'm going to take those two and subtract them from 180 to find angle A2. So 180 minus 143.66 minus 30. And I get 6.34. So now I've got angle C2, angle A2, and the last thing I need to find, which is side A2. I'm still going to use the same original measurements that I got given for B. So 27 over the sine of angle B, which is 30, would equal A2 over the sine of angle A2, which is 6.34. Cross multiply, so 27 times the sine of 6.34 divided by the sine of 30. And I get A2 equals 5.963, so 96. And there I have my 2 full complete triangles. Okay, the last part of 6-1 was the area when you were given side angle side. So this would be if I was given any 2 sides and the included angle, you're going to actually see all 3 letters represented by that. So here I have A, I have B, and I have C, 1 of each one. Okay, same thing would happen with any of the other letters, but you'd get 1 of each one. 1 angle, 2 sides. So we use this formula, but we're going to change it up this time to make sense for what we have. So we have angle A, side B, and side C. So it's 1/2 side B times side C times the sine of 52. And a couple of people made mistakes on the quiz by making this cosine. Make sure that you are using sine for this formula. So 1/2 times 7 times 8 times the sine of 52 is 22.06. And this would be unit squared because there's no specific unit given. So this is another formula you want to remember. And then we got to law of cosines, and all of those formulas are there on the right. You need to know all of those. We use law of cosines for side, angle side, and also side, side, side. So if we had side, angle side, I would have to find the remaining side first by using the standard form, one of the ones on the top. And for side, 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 you're always going to start with the largest angle first. So if I'm given A is 12, B is 17, and C is 20, then I want to find angle C first. So the cosine of C is A squared plus B squared minus C squared over 2AB. So 12 squared plus 17 squared minus 20 squared over 2 times 12 times 17. You can type this all in your calculator at once, so I can do cosine -1, but you have to be careful and make sure that you group together your numerator and your denominator. So I would do second cosine, open my parentheses, 12 squared plus 17 squared minus 20 squared, close the parentheses, divided by, open the parentheses, 2 times 12 times 17. And then close those parentheses again. And I get that angle C, which is the first one we're finding, would be 85.36 degrees. So now we can stick with law of cosines and continue to use it to find the other angles, or we can switch and use law of sines as long as you've found that first angle first. The biggest angle first. So I'm going to stick to law of cosines just so that we can see, get more practice with it. So the next one would be, let's say we're going to find cosine A. I would do B squared plus C squared minus A squared over 2BC. So I'm going to type in my calculator, cosine -1, B squared, which is 17, C squared, which is 20, minus A, which is 12 squared, over 2 times 17 times 20. And then again, let the calculator do the work. Just be really careful when we group it. 17 squared plus 20 squared minus 12 squared divided by 2 times 17 times 20. And I get angle A is 36.729, so 73 degrees. And then it's a triangle, so all three angles add up to 180. I just have to subtract these two from 180. And I get the remaining angle, which was angle B. And that's 57.91 degrees. And now you've got all three angles for this triangle. Also in 6.2 was Heron's formula. So this is when you're finding area given all three sides. The first thing you have to do is find S, and S is A plus B plus C divided by 2. And then you'll find the area by doing the square root of S times S minus A times S minus B times S minus C. So you just got to plug them in. So if I gave you 3 side lengths, add them up, divide by 2, you get that. Do not round that S. That's the only thing that mistakes are made on the quiz with the rounding. You don't want to round S. And then you'd get the square root of S times S minus A times S minus B times S minus C. And that's your area. There will be one word problem, and it will either be law of sines or law of cosines, depending on the version of your test. So just make sure that you've practiced those word problems. There's a bunch for the quiz review, on the quiz, some in the homework, and on the review for the test. 6.3 was vectors. So with vectors, we started with component form and magnitude. If you remember component form, it is the x of the terminal minus the x of the original, comma, the y of the terminal minus the y of the original or the initial. So if I'm given the initials 2 and -5 and terminal is -7, 6, and I want to find the component form, I would have -7 minus 2, comma, 6 minus a -5. So I get -9, and then this becomes plus, and that's 11. That's the component form of this vector. Magnitude is found 2 different ways. The distance, so the square root of x2 minus x1 squared plus y2 minus y1 squared. Or the square root of a squared plus b squared if you already have the vector in component form. So we already do. I have -9 and 11, which means I can find the magnitude by doing -9 squared plus 11 squared. I get 81 plus 121. And I get 202. So you want to make sure that you can't simplify that. 2 would go in there 101 times, and then 101 doesn't break down at all. So this is as far as you go. Remember, if there was a name for this vector, so if this said this was vector V, let's just say, then I would say V equals that, and that's the component form. And I would say the magnitude of V equals square root of 202. The unit vector in the same direction is where you put the component form. So I would put the component form of my vector over the magnitude of that same vector and then simplify it. So if we use what we just did, I would get -9, 11 over the square root of 202. And then I would break that up. So it's -9 over root 202 and 11 over root 202. And then rationalize. So -9 root 202 over 202. And then 11 root 202 over 202. So that would be a unit vector in the same direction as our initial vector. All right, then we had the properties of vectors. So we were adding, multiplying, or not really multiplying, multiplying by a scalar, subtracting, and then identifying if the result was a vector or a scalar, and also graphing these. So remember, if it's a vector, it's going to be in component form, and if it's a scalar, it means a single number. So if I look at this first one, I get u is 2, -3, v is 1, 4, and I want to find u plus v. to do that, I add the first 2 in each. So 2 plus 1 is 3. And then I add the second 2 in each. Negative 3 plus 4 is 1. If I wanted to graph this, then I would start at 0, 0. And I would go to the right 3 and up 1. B says, oh, and this is a vector because it's in vector form. B says 3v minus u. So the first thing I'm actually going to do is 3v. So this is 3 times 1, 4, which is 3, 12. And then I'm going to subtract from it u, which is 2, negative 3. So 3 minus 2 is 1. 12 minus a negative 3 becomes 12 plus 3, which is 15. And then again, this is a vector. And if you wanted to graph it, you would start at 0. You go up 1, to the right 1, and then up 15. And that would be your graphed result. You also want to know how to do all this stuff in terms of I and j. So if this instead said 2i minus 3j, and this said I plus 4j, you would do the same thing for all of them, except at the end, you would also make sure that it's back in that same format. So if this is given to you in IJ format, then these answers need to be written back in IJ format. So it would be something like that. This is just another example of what we did already for the unit vector. So this is like, instead of it saying, okay, here is the component form and here's the magnitude already, it could just ask you straight from this point. So I would say that that's my component form. So 1, 4 would go over the magnitude, square root of 1 squared plus 4 squared, 1 plus 16, which is square root 17. And then that would be 1 root 17, 4 over root 17, and then we'd rationalize it. So this would be root 17 over 17, and then 4 root 17 over 17. So that's the unit vector in the same direction. 6-4 was dot product. The angle between n, identifying if it was orthogonal or parallel, and or neither. So the dot product, hopefully we remember, is multiplying the first term in each one, the second term in each one, and then adding them together. So if I'm doing u dot v, it's 2 times 1 plus negative 3 times 4. So I'd get 2 minus 12, which is negative 10. That's the dot product. The angle between the two is the cosine of theta equals the dot product over the product of the magnitudes. So cosine of theta in this case would be the dot product, which you said was negative 10, over the magnitude of u, so magnitude of 2, negative 3, square root of 2 squared, which is 4, plus negative 3 squared, which is 9, square root 13. And the magnitude of v, square root of 1 squared, which is 1, square root of, then 4 squared, which is 16, square root 17. And then if you want to type that in your calculator all at once, you can. Just make sure you do cosine negative 1, because we're finding the angle. Negative 10 divided by, open up those parentheses, square root 13 times the square root of 17. And you can put 13 and 17 both underneath the same square root as long as you put the multiplication in there. So negative 10 divided by square root, open my parentheses, square root 13 times 17. And I get the theta is 132.27. And we talked about a good way to check these is approximate what they would look like. So 2, negative 3 would be something like this. 1, 4, 1, 2, 3, 4 would be something like this. And we're looking at the angle between these. This is clearly obtuse, which matches our 132. All right, and then we finish 6-4 with orthogonal or parallel vectors. So the question is, if they, to be orthogonal, the dot product would be equal to 0. Or if you did your rise over run, they would be opposite reciprocal. And then parallel, the rise over 1 would be the same. So if I had just like, for example, these up here, if I take u and v, and I found the dot product, I'd know it's -10. That makes this not orthogonal. And then if I had taken the change in y, which is -3, over the change in x, which is 2, and compared it to the change in y of the second one over the change in x, which is 1, these are not equal, which means that these would be neither parallel nor orthogonal. All right, the last part of the chapter was 6.5, and this is the trig form of complex numbers. So for the first part, it said to plot the complex number and then find its absolute value. So hopefully you remember that the number that's without the I is your A, which is going to be the X. When we write it into a coordinate point, this would be 4. And then the one attached to the I, which is -5, is your B. And the vertical change on your coordinate grid. So on a complex number grid, the x-axis is your real part, and the y-axis is your imaginary. So I would go 4, 1, 2, 3, 4, -5, 1, 2, 3, 4, 5. And it's just a point, so it stays just the way that it is. The second part of this said find its absolute value. So remember, the absolute value is the distance from the 0, 0 to that point. We could have set up a triangle, done Pythagorean theorem to find it, or treat it like it's a vector, found the magnitude. Either way, you get the same formula. So the absolute value is the square root of a squared plus b squared, which is 4 squared plus -5 squared, 16 plus 25, which is the square root of 41. And then if it is able to be simplified, I would simplify it. In this case, it's not, so it stays as the square root of 41. All right, the last part of 6.5 and what's covered on your test is finding the trig form of the complex number. So you're going to get given a complex number like this one is here, and you want to find the trig form. So z equals r times the cosine of theta plus I times the sine of theta. So this is what our resulting answer is going to look like. You're going to have a number on the front, that is your r, and then you're going to plug in for theta. So I would plot this first to try to get an idea of where you're looking, so that you can figure that out with your theta in a little bit. So again, root 3, not a perfect square, but let's just say that's 1.5 because it's in between. It's probably closer to 2, but it's in between 1 and 4. And you have a calculator, so you could actually figure that out, what it is, which is actually 1.7. So let's do that. But we're only approximating it because we want to know where to graph this. And then that times 3, 5.1. So now let's say that we, that's my x coordinate, and then what's in front of the I is your y coordinate. So I know I'm going over 1, 2, 3, 4, 5, a little bigger than 5, and up 1, 2, 3. So I know this is in the first quadrant. That's the first thing I can tell you. Then I know that theta is going to lie somewhere in the first quadrant. Then the next thing I want to find is r. So r equals the square root of a squared plus b squared. In this case, a squared would be 3 root 3, b 3. I get the square root of 3 squared, which is 9, times root 3, which is 3. 9 times 3 is 27, plus 9. And I get the square root of 36, which is actually a perfect square, which is 6. That's my radius. Then I want to find theta. So I know that the tangent of theta is b over a. So I would do tangent -1 of b over a, and in this case, that's tangent -1 of b, which is 3, over a, which is 3 root 3. Now, this is not already on my unit circle, but this simplifies to be 1 over root 3, which gets rationalized to root 3 over 3. And that, remember, is the over 6. So all over 6s on your unit circle are going to be root 3 over 3. I want the over 6 that's in the first quadrant. So I know that this is pi over 6. So then the last thing I have to do is plug that all into my formula. So z equals r, which is 6, times the cosine of pi over 6, plus I times the sine of pi over 6. And that is my answer. And then remember, these are easy to check. So if I actually worked that back out, I know that the cosine at pi over 6, so we know this point here is root 3 over 2 and 1/2. So this would be root 3 over 2 plus I times 1/2. And then I would distribute this in. 2 goes into 6 3 times. That's 3 root 3 plus I and 1/2 of 6, which is 3. If you look, this matches my original question. So these are easy to check when you have the extra time. And these answers will be kept exact, so I won't plug this into my calculator to get the actual cosine. You'll keep it in this format. All right, that wraps up the chapter review, so you can start to work on your assignment. Good luck.